Welcome to the Deep Dive. Ready to explore something fascinating? Today it's the world of information retrieval, or as the cool kids call it, IR.
IR it is.
We've got excerpts from Introduction to Information Retrieval by Christopher Manning, and let me tell you, this goes way beyond a simple Google search.
Oh, absolutely. It's way more than that.
Manning starts by breaking down IR into these different scales: web, personal, enterprise. Where do you think we should even begin?
Well, since we're all about making this relatable, let's start with personal IR.
Yeah, personal IR. Makes sense to me. What exactly falls under that umbrella?
Well, think about the search bar on your computer. You know, the one you use to find files in a flash. That's personal IR in action.
Oh, right. It's so seamless I almost forget. There's some serious technology making that happen.
Exactly. And it's not just about finding files on your computer either. Think about managing emails, your browsing history, even photos. Manning even uses Apple's Spotlight and Windows Instant Search as prime examples. You know, those tools we use every day without even thinking twice.
It's true. We totally take those tools for granted. But let's zoom out for a second. What about the big leagues? I'm talking web search now. That's a whole different beast.
Oh, absolutely. It's mind-boggling when you think about it. Billions of web pages out there, constantly changing, and somehow search engines manage to make sense of it all.
Trying to find a needle in the world's biggest haystack? That's what it feels like.
And then you've got enterprise IR, which is all about companies managing their internal data. Think emails, documents, databases. It's a whole other level of information overload.
Okay, so we've covered the where of IR, but now I'm really curious about the how. Have you ever started typing a query and wondered what actually happens between hitting enter and seeing those results pop up?
Happens to me all the time. It feels kind of like magic, right?
Totally, like I'm speaking to the internet gods or something.
But in reality, it's way more intricate than just matching words. Manning really emphasizes that it's about understanding your intent, not just the words themselves.
Okay, so spill the tea. What's actually going on behind the scenes?
Well, he breaks down the search process into these different steps. One of the first things he mentions is tokenization.
Tokenization. Sounds kind of technical.
It is, but it's also pretty cool. It's basically how the system breaks down your query into individual words or phrases. Think of it as the search engine trying to understand what you're asking, word by word.
So if I search for running shoes, it's not just seeing that whole phrase as one thing. It's breaking it down.
Exactly. It's these running, and it's these shoes, and then it has to figure out how those words relate to each other.
So it's like the search engine is reading my mind word by word.
In a way, yeah. But it's not always as simple as it sounds. Think about it. A basic search might miss shoes if I wrote shoe in its possessive form, or it might misinterpret running as in running a marathon.
You're right. It needs to understand that I'm looking for footwear, not signing up for a race.
Exactly. That's where normalization and stemming come in.
Okay, more technical terms. Break those down for me.
Sure. These techniques help bridge those gaps, ensuring a more accurate search experience. For example, stemming reduces words to their root form. So running, runner, and ran would all be connected.
So it's like teaching the search engine to speak our language, with all its quirks and variations.
You got it. And it gets even more interesting when you start thinking about foreign languages.
Oh, right, because search in English is totally different from buscar in Spanish or rechercher in French.
Exactly. And Manning explains that a single index might contain terms from various languages, which means the system needs to be multilingual too.
Wow, it's like the United Nations of search engines. Okay, so we've got all these different languages, but what about those tricky phrases? Like if I search for Stanford University, I don't want a bunch of results for Stanford, Connecticut.
Good point. Context is key.
The words Stanford and university mean something totally different together than they do separately.
You're absolutely right. And to tackle that, Manning introduces this really cool concept called positional indexes.
Positional indexes.
Yeah.
Okay, I'm intrigued. Tell me more.
So instead of just noting which documents contain certain words, these indexes track the exact position of each word.
It's not just finding the words, but understanding their order. Like, it's the difference between having all the ingredients for a cake versus actually having the recipe, right?
Perfect analogy. Positional indexes are like the recipe books of the IR world. They tell the search engine not only what ingredients are present, but also the order in which they appear.
That makes total sense. So we've gone from breaking down words to understanding their order. But what about those multi-word concepts? Like, how does the system know that artificial intelligence is one thing, not just two random words?
Great question. Manning talks about something called byword indexes, which is when the system treats those multi-word concepts as a single term.
Ah, so artificial intelligence becomes one ingredient in our recipe book.
Precisely. But there's a catch. He points out that as those phrases get longer and longer, things can get a bit messy and inefficient.
So back to our trusty positional indexes to save the day.
You got it. They can handle even the most complex phrase queries, making sure those multi-word concepts are understood in context.
Okay, so we've talked about how the system breaks down our searches, understands those relationships between words, but how does it actually find the terms we're looking for? It's not like it's sifting through every single word of every single document every time we search right.
You're right, that would take way too long. That's where dictionaries come in.
Dictionaries, like actual dictionaries.
Well, kind of. Imagine a giant, super organized index for all the words and phrases the search engine knows about.
So like the ultimate vocabulary list for the entire internet.
Exactly. And just like a regular dictionary helps you find words quickly, this search dictionary helps the system instantly know if a term is even in its index.
It makes sense. But how does it actually work? Is it just one massive alphabetical list?
It's a bit more sophisticated than that. Manning talks about how there are different ways to build these dictionaries. One way is called hashing, which is all about speed.
Speed is definitely key when you're talking about something as vast as the internet. Every millisecond counts, right?
Right. But Manning points out that hashing can be a bit limited when it comes to certain types of queries, like wildcard searches.
Ah, those are my favorite. When you only remember part of a word and try to fill in the blanks.
Exactly. For those, search trees, especially a type called B trees, are much more efficient.
So depending on what we search for, the system might use a different method for finding those terms.
Exactly. It's all about using the right tool for the job. But even the most advanced dictionaries can't always account for human error.
Oh, tell me about it. I'm the queen of typos. So how do search engines handle those "did you mean" moments?
Well, Manning talks about this cool concept called edit distance.
Edit distance. Okay, I'm listening.
It's basically a way for the system to measure how many changes it would take to transform one string of letters into another.
So it's figuring out how close my misspells word is to a word it actually knows.
Exactly. And then it can suggest the correct spelling. It's like a spell checker on steroids.
That's seriously impressive. But what about words that sound alike but are spelled differently, like here and here?
That's where things get even more interesting. Manning talks about this other technique called K-gram overlap.
K-gram overlap. Another tongue twister.
It's a mouthful, I know. Basically, it breaks down words into smaller chunks of letters. He uses the example of board and boardroom. Even though they're not exactly the same, they share several K-grams, indicating a potential relationship.
So even if I make a typo, the system can still find words that are similar, both in spelling and meaning.
You got it. And here's the kicker. It does all of this in a fraction of a second, even with billions of web pages to consider.
Okay, now that's just mind-blowing. We've talked about dictionaries, typos, even foreign languages. What else is there to consider when building a search engine?
Well, Manning emphasizes the importance of efficiency. He introduces this thing called Zipf's law, which basically says that a small number of words make up the bulk of any text.
So words like the, and, those kinds of common words.
Exactly. They appear way more often than less common words. And knowing this, engineers can actually optimize how the system stores and retrieves information.
That makes sense. If a word appears a lot, you want to make sure it's easy to find.
Exactly. And then Manning gets into some pretty technical stuff about compression techniques, like gamma codes.
Okay, those sound a bit over my head, I'm not going to lie. Can you give me the gist?
Basically, it's all about representing data as efficiently as possible. Kind of like packing a suitcase strategically, rolling your clothes instead of folding them to save space. These techniques help to ensure those searches happen lightning fast, even with billions of documents in the mix.
So it's like a delicate balancing act, making sure the system is fast, accurate, A&D can handle all sorts of different queries.
Exactly. And we haven't even touched on the most important part yet, how the system decides which results are the most relevant.
Okay, so we've covered dictionaries, typos, compression, foreign languages, so much. It's really amazing how much complexity goes into something we use every single day.
Right. And it all leads up to that moment of truth, seeing those search results. But it's not just about finding any results, is it?
No, not at all. If I search for best pizza near me, the last thing I want is to read about the history of pizza ovens.
Exactly. That's where things get really interesting. Manning emphasizes that relevance isn't just about matching keywords. It's about understanding the user's intent.
Okay, so break that down for me. What does that actually mean?
Well, he uses this example of someone searching for information on the health benefits of red wine versus white wine.
Okay, interesting example.
So a truly relevant document would address that specific question, not just contain the words wine, red, white, health. You see what I mean?
Yeah, it's like the system needs to be able to tell the difference between me wanting to, like, BUY a pizza versus wanting to write a research paper on the cultural significance of pizza.
Exactly. It's about going beyond the literal words and understanding the meaning behind them. And that, let me tell you, is one of the biggest challenges in IR.
I bet. So how do they even begin to measure something as subjective as relevance?
It starts with understanding that there are different levels of relevance, right?
Right.
Some documents might be a perfect match for your query, while others might be, tangentially related.
Makes sense. Like if I search for best chocolate chip cookie recipe, I might get results for bakeries near me, even though that's not exactly what I asked for.
Exactly. And to measure all of this, researchers use something called ranked retrieval. Remember the vector space model we talked about earlier?
Vaguely.
Yeah.
Maybe time for a refresher.
Sure. It's that idea of plotting points on a graph, where each point represents a document or a query, and the closer those points are, the more similar they are.
Okay, starting to ring a bell.
So with ranked retrieval, the system uses this model to actually calculate a relevance score for each document and then ranks them accordingly.
So the higher the score, the more relevant the result.
You got it. And to calculate these scores, they use a bunch of different factors, one of the most important being something called TF-IDF.
TF-IDF. Okay, I'm going to need that one broken down. What in the world does that stand for?
It stands for Term Frequency Inverse Document Frequency. Basically, it's a way of figuring out how important a word is to a document within a collection of documents.
Okay, so if I'm searching for that best chocolate chip cookie recipe and a document mentions chocolate chip cookies a lot, that document would get a higher score.
Exactly. That's the term frequency part. But it also considers how rare a word is across all the documents.
So a word like chocolate might appear in a lot of recipes, but a word like caramel might be less common.
Exactly. So a recipe that includes both chocolate chip cookies and caramel, that's like a rare gem.
Haha, a rare gem. I like that.
Yeah.
That's the inverse document frequency part.
You got it. It's all about finding those words that are most unique and relevant to your specific search.
Wow, this is fascinating stuff. So TF-IDF helps the system prioritize the most relevant results. But what about those times when we're not even sure what we're looking for? Or we just want to explore a topic broadly?
That's where things get even more complex, and we start moving into the realm of, exploratory search. It's a whole other area of research.
That does sound like a whole other deep dive. But for now, I think we've done a pretty epic job of, unpacking the basics of information retrieval.
I agree. We've gone from the different types of IR systems to the techniques used for processing language, handling errors, ranking results. It's quite a journey.
And we've learned that it's not just about matching keywords. It's about understanding the user's intent and delivering the most relevant information possible, which, as we've learned, is no easy feat.
Not easy at all. But that's what makes it so fascinating, right?
Absolutely. Well, a huge thank you to you for breaking it all down in such an understandable way, and to Christopher Manning for his incredible work in this field. And to you, dear listeners, for joining us on this deep dive into the world of information retrieval. We'll catch you next time for another fascinating exploration.